Hey guys, all right, so let's just tackle worksheet number 5. So I've got a new little tool. Some of you know about it, some of you don't know about it, but let's see where I'm at here. Let's see where I'm at with the writing part. Okay, so worksheet 25, what we're going into is kind of this wild little crazed piece, let's say. Let's just kind of this is kind of a review for us today. Oh, the first thing I want you guys to know is don't do number 8. Number 8. So number 8 on worksheet 65, don't do. So I'll have to go through these because these are worksheets that we normally used to do later. I'll have to adjust them and make sure that you don't have anything new in there. Other than that, I think you're good. And you should be able to. So number 8, don't do. So let's just assume we have this graph of x cubed plus 1. Let's just look at that right there. So if we look at that and we take our graph paper here and I put an axis right there and I put an axis right here. And that's a little bit off, but that's all right. So let me get a different color here. And we look at graphing this thing. And we say that, you know what? I don't like this one. Let's do a little bit different one here. Let's just say, let me write it differently because I got to be able to talk to you guys about a little different one here. So let's do x, and let's do x squared minus 4. That's an x cubed. So that one's going to be something that writes like this, x cubed minus 4x. Okay, so that's our original function. There's a reason I chose that one. So if we take this, we know that we have an x-intercept at 0. We also know we have an x-intercept at plus or minus 2. So if we graph this on our calculator, we're going to get an x-intercept here, and we're going to go over to 2, and we're going to get 1 here, and we're going to get 1 right there. So we're at negative 2 here, and we're also at 2 right here. So if we look at this graph, and this is where I won't be very good at this graph is not very good. So we go here, and then we go down like this, and then we go like that. Something like that, right? Oh, man, that's horrible. I'll get better at this, I hope. Okay, so when we look at this, we have critical points. So our first critical points are our x-intercepts, okay? So our x-intercepts. So if we labeled our x-intercepts, we're going to have them at negative 2, 0, and 2. Now, for this particular graph, we also have what is going to be considered. No, I don't want that color. Let's look what rainbow looks like. Let's try it. So we also have these points right here. Well, that's crazy. And woo, look at that rainbow color. And this point here, which is going to be, let's say, right here and right here. And those are our maximums and our minimum. So, but the question is, how do we find those? So here's the idea. If we take this idea of, let's go to the pencil here. Is it not? Come on. I think my hand's on it too much. Let's take the idea that just a regular. If I look at this and I say, okay, well, if I draw a line here and draw a tangent line there, those are tangent lines. Well, the tangent line slope is equal to 0. So to find your maximum and minimum points, you can take the derivative of this thing. So you can take f prime of x, And we can go, oh, okay, well, that's going to be 3x squared minus 4, right? And I know that this at a maximum and minimum is equal to 0. So then I could say, well, 3x squared minus 4 equals 0. And then I get 3x squared equals 4. X squared equals 4/3. And that means x equals plus or minus 2 over the square root of 3. So at this right here is going to be where a maximum and minimum point are located. So this is where my max and mins are located. So how do I find that exact point? Well, I'm going to take this and I'm going to plug it in to my original equation here. So if I want to find my max and min, my first one's going to be at f of x equals 2 root 3, and this is where your calculator is great to use, 2 root 3 cubed plus 4 times root 3, 2 over root 3. And then my other point is going to be f of x equals negative 2 root 3 cubed plus 4 times, oops, that's a 4. Let's just erase all that because that is just flat out horrible. Plus 4 times negative 2 root 3. And so those two pieces will become my maximum and minimum. So this one in general, because I know just because of the way this looks, my negative root 3 is going to end up becoming a maximum because it's right here. And then this will become a minimum. So my point here would be 2 root 3 and plus whatever f of x I get when I plug that in. So the whole idea of this first worksheet is to do a couple of things. Number one is to label your critical points, which are your x-intercepts. You find your max and minimums by setting your derivative equal to 0, because that's going to be the slope of the tangent line is equal to 0. And then once you find that, you plug it into the original to get your points. So we want to label the points specifically. And then the last thing they want you to do is find the intervals where it's increasing and decreasing. And so we'll just take, let me change colors here, or pens. Let's do purple here. So we know that this thing is increasing from here down this way. So I am increasing from negative infinity until I reach my maximum point, which is going to be at negative root 2 over 3. Oops, where am I at here? Where'd I go? There I am. Negative 2 over root 3. And I'm going to increase from root, this should be yeah, it's not going to be because that's 0. Sorry, that's correct. This is going to be from 2 root 3 to, it just keeps going on forever. Sorry about that line over there. This is going to be positive infinity. So those are my intervals that it's increasing on. And so then if I look at this a little differently and say, okay, where is it decreasing? It's decreasing where I'm going to make it yellow right here. I'm sorry about the writing, guys. I'm getting used to this. Perfect thing to do. So I need to know that it's decreasing from negative 2 root 3 to 2 root 3. So when they ask you for all the different pieces, they're going to ask you to find your max-mins, your x-intercepts, and your increasing and decreasing. So since this was a total crazy mess, let's just talk about how we're going to tackle that. So we're going to tackle it this way. Step 1, factor set equal to 0 to find your x-intercepts. Step 2, we're going to take the derivative, set it equal to 0 to find your x values, and then we're going to use that to find our maximum and minimum points. Okay. Step 3, I would graph it at this point, then find intervals for increasing. So when the slope is increasing, and then find the interval for when the slope is decreasing. Okay. So that's the main idea of 65. There's a few other thinking problems, a couple of review problems in there. Don't forget, do not do number 8. But that should get you through number 5, and I'll make sure I can write it a lot cleaner here soon. All right, guys. Talk to you soon. I got to figure out how to stop this thing. Interesting. It disappeared. There it is.